This conference will now be recorded.
Very good evening, students. Welcome to this PYQ discussion series on JEE Mains paper. So we have been discussing the numerical problems from the JEE Mains paper 2021, and the exam was on 26th August, shift 2. That paper we have been discussing. In the previous class, I had discussed some numerical problems or some questions from 11th standard. Today I am going to discuss the questions asked from the 12th portion. Okay, so let us start our discussions. So the first problem says an electric bulb of 500 watt at 100 volt is used in a circuit having 200 volt supply. Okay, so bulb is actually specified to be operated in this. Okay, power delivered by the bulb will be 100 watt when it is given 100 volt or it is connected across 100 volt. Okay, supply. Now the question is, the same bulb is connected now to a circuit where you have 200 volt supply. Calculate the resistance R to be connected in the series so that the power delivered by the bulb is not changing. Okay, that will be 500 watt itself. So now I'll just tell you once again, there is a bulb specified by 500 watt power delivered or generated by a bulb when it is connected to a source of 100 volt. But if the same bulb is connected to 200 volt supply, then in that circuit you have to connect certain resistance in series to get the same amount of wattage. Okay, power delivered by the bulb. So what is that resistance? First of all, let me find out what is the power allowed current through the bulb. So how do I get P is equal to VI? So I get allowed current through the bulb, that is P by V, right? So 500 watt by 100. So this is in ampere. So what is the allowed current through the bulb? That is 5 ampere. Beyond that you cannot pass. Then the bulb will be fused. Okay, or it will be burnt. The fuse wire will be burnt. Okay, so calculate. See, now you have been given a circuit where there is power supply 200 volt. How much extra resistance you have to apply in the connect in the series with the bulb? Okay, so for that you need to find out what is the resistance of the bulb itself. Let us find out what is the resistance of the bulb. See, we know P is equal to V square by R, right? So what is the resistance of the bulb? That is V square by P, and P is, so 500 into 500, sorry, V square, V is 100. So 100 into 100 divided by 500. V square by P. Okay, so V square is 100 into 100 divided by 500, sorry, 500, this one. Okay, so you get 20 ohm. So this is the resistance the bulb has. Okay, the bulb has this amount of resistance. Now look, if I have to keep the same power, if the bulb has to deliver the same power with this voltage, with the same current I, with the same current I, the same current, this one, this is going to VI, right? Same current I, then what should be the resistance? Okay, what should be the resistance in that case? See, you have, see, second case, you have this much of watt, you have been given P is equal to 200. Okay, this is volt, and see the current through the bulb will not change. This is its capacity, so this much ampere you have to supply, like current has to be this much only. Okay, so to get the same power this much with this current, what would be the total resistance in the circuit? What should be the resistance in the circuit, or what should be the resistance of the bulb in that case? In that case, resistance of the bulb should be 200 V by I. Okay, V by 5 ampere. Okay, V by I. Okay, this is in volt, this is in ampere, so this will give you 20 ohm. So this much is the total resistance the circuit should have. Okay, including the bulb. And we have already found out that bulb has resistance 20 ohm. So how much extra resistance you have to connect in the series? That is this R minus 20, which is 40 minus 20 ohm. So that is actually 20 ohm, right? I hope you have understood this. Okay, so to see, if we connect the bulb with the power supply 200 volt, you have to add 120 ohm resistor in series with the bulb to get the same amount of wattage. Okay, this is the answer. So option A will be the answer for this question. Okay, next let us try to solve this. This question says, if you are provided a set of resistance 2 ohm, 4 ohm, 6 ohm, then 8 ohm, connect these resistances so as to obtain an equivalent resistance of 46 by 3. 46 by 3. Okay, so for that, which combination you have to use? Combination means, say, you have to connect the resistors in either parallel or series. If you connect any resistance in series, like which one you want to keep in series and which one, how many you have to keep in series, how many you have to keep in parallel, that you have to find out. You look here, there are options 4 ohm and 6 ohm are in parallel connection, and 2 ohm and 8 ohm will be in series connection. Let us see, in series connection we know this will be 10 for the first option. Let us just verify, that's all. And this in parallel. So these are in parallel with this in series. That means this is 2 ohm, this is 8 ohm, this is 4 ohm, and this is 6 ohm. We'll just verify each and like all the options, then we'll get it. See, for this we know what we'll get, multiplied by like see for multiplication by division, right? Sorry, addition. Multiplication divided by addition, that is 10 here. Okay, so along with this you will get 10 here. Okay, so you can actually see here what you get. This will be 100 plus this one. Okay, 10. So 110 by 10. But now we can actually just do this. 2 2s are 4, 2 2 5s are 10. Okay, so 12, and this is, so 12 by 5, 12 by 5 plus this. So this will be actually 62 by 5. Okay, so this is not the combination. Okay, let us do one thing. I'll keep the combination. Only what I'll do, I'll just change the registers according to the options given. So 6 and 8, and here it is 2 and 4. Let us see that. So this will be 8 into 6 divided by 14 plus 2 and 4, right? 6. So you look this, right? So this will be 24 by 7 plus 6. So I have to get this, right? Since 7 is there, will not get the same. So this is also not true. Let us see with the third option, 2 2. Okay, 2 2 are in parallel. Sorry, 2 and 4, this one. So 2 4 6, I think this may be the option. This is 14, right? So this may be the option. Okay, so this is, yes, 46 by 3. Okay, so third option will be the correct answer for this question. All right, so third option, that means 2 ohm and 4 ohm should be in parallel connection, and 6 and 8 should be in series combination. Okay, with that, so this will give you equivalent resistance 46 by 3 ohm. So which was being asked here. All right, so this was also a very simple question, but it takes little time. All right, now the de Broglie wavelength of a particle having kinetic energy E is equal to lambda. How much extra energy must be given to the particle so that the de Broglie wavelength reduces to 75% of the initial value? Okay, so let us first find out what is the expression for the de Broglie wavelength when we have kinetic energy known. Okay, so we know p square by 2m is equal to E. Okay, so P is square root of 2ma. Then we have lambda is equal to H by P. So H by square root of 2m into E, right? So what is this? Lambda is inversely proportional to square root of E. Okay, now we'll just quickly, so this is lambda, so I have already written here. Now look, I'll just put lambda to lambda 1, lambda 2 by lambda 1. Then we'll get square root of E2 by E1, right? Right? I'm sorry, this is E2, this is E1. E1. Or let us write under the same square root E1 by E2. Okay, so this is the thing. If I take the ratio, now let me write down what is lambda 2. Lambda 2 is actually 75% of lambda 1. That means it is 75 by 100 into lambda 1, that is further 3 by 4 lambda 1. Let us put this here. Okay, if I put lambda 2 is equal to 3 by 4 lambda 1, then what I get, 3 by 4 is equal to square root of E1 by E2. Now let us square this out, then I get 9 by 16. Okay, 9 by 16, so I'm sorry, this will be E2 by E1, E1, sorry, E1 by E2, that is fine. Okay, so E2 by E1, E2 by E1, 16 by 9 E1. Okay, look here the option, see this is the option, 16 by 9. Okay, so this no, I have to see, I see, actually this will be different. Let me just tell you, this is not the option. You have to give extra energy. How much extra energy? That means extra energy means you have to, so E2 is the total energy, right? So you have to minus from here. You have to just take 16 by 9 E minus E. So this is the, this will be extra energy. Okay, let me write that as delta E, extra energy. So 7 by 9 E. Okay, 7 by 9 E. So last option will be the correct answer for this question. Okay, 7 by 9 E. Now let us go to the next problem. This problem is very, very interesting. So this problem says in the given circuit, okay, so in the given circuit, the AC source has frequency, angular frequency given 100 rad per second, okay, radian per second. Considering the inductor and the capacitor to be ideal, that means they don't have resistance associated with that. Okay, that will be, okay, so what will be the current I flowing through the circuit? Okay, what will be the current flowing through the circuit? So first of all, let me tell you here, options are actually not correct. Okay, so options are not correct here. I'll show you these options are not correct. None of these will be correct according to the given informations in the problem. Okay, we'll just carry out the solution. Okay, let us carry out. See here, uh, this is CR circuit and this is actually LR circuit. All right. So now I have got two branches for the current to flow. Two branches for the current to flow. One through the LR circuit, another through the CR circuit. Okay. So obviously the current will be divided into two parts, right? See, these are in parallel combination. Suppose I have two resistance. If I know two, or if I know here two impedances, okay, so just a minute. Yeah. So if I know the resistance of this or impedance of this CR circuit, okay, and impedance of the LR branch, I can find out the current I1 and I2 through this, okay, and then I have to apply the phasor diagram method to find out the total current in the circuit. Okay, so what is ZCR CR circuit? That is actually R square plus XC square. X is the capacitive reactance. Okay, so what is XC? 1 over omega into C. What is omega? That is given 100. What is C? So 100 into 10 to the power minus, sorry, 10 to the power, see, 100 micro farad, 10 to the power minus 6, 100 into 10 to the power minus 6. So this is 4, this is 4. So 10 to the power minus 2 will be remaining, and that will be 100 then. Okay, this will be 100 ohm. So XC is 100 ohm. Okay, so we can now find out what is ZCR. Square root of, see, R is given 100, X is XC is also 100. So 100 square root 2 into 100, 200, it will be 200 square, 2 into 100 square, right? 2 into 100 square means 100 square, I'm sorry, yeah, so 100 square, that means sorry, yes, this is 2 into 100 square. Okay, so 100 square root will be 100 only. Yes, let us find out what is this. So this will be actually 200. Sorry, root 2 into 100. I'm sorry, root 2 into 100 here. Okay, so then it will be root 2 into 100. Let us go ahead and see how much we are getting. So this is much, this much ohm. Okay, then okay, so similarly, okay, so for this, I can find out what is I1. I1 is 200 divided by Z, okay, divided by ZC, ZCR, okay, ZCR. So what you get? 20 volt, right? This 20 volt. was this 20 volt? Let me cross check the question whether it was 20 volt or 200 volt. But anyway, for this circuit also we can go ahead. 200 divided by this into 100. Okay, this will be 5, right? So let us just multiply root 2 both places. So I'll get root 2 by 10. Okay, I'll get root 2 by 10 ampere. Let us just skip this itself. Whatever we have been given in the circuit, let us just go ahead. So for the other case like, what is ZLR? Square root of XL square plus R square. XL is how much? XL is omega into L. What is omega? What is L? Let us see. Omega is 100, L is 0.5. So into 0.5, that will give you 50. Okay, 50. Now what is R in this branch? That is also 50. Let us go ahead. So 50 square plus 50 square. How much you get? You get root 2 into 50 square. That means 50 here. Okay, root 2 into 50. So how much is the current I, LR or I1, I2? This one. I1 we have already got. I2 is this much. What is I2? I2 is V, that is 20 volt by ZLR. ZLR is this into 50, right? So here also, if we do this, let me multiply root 2, okay, or we'll get here root 2 by 5, root 2 by 5. Okay, so earlier we had got root 2 by 10, now we are getting root 2 by this. Okay, so dear students, what we have got, I'll just clean this portion and write the results we have got so far. So I1 I have got root 2 by 10 ampere, and I2 I have got root 2 by 5 ampere. Okay, this is so far so fine, but how do I get the resultant of this two? I have to find out the angle between these two vectors. These are actually kind of vectors. Okay, kind of vectors. So these two are actually kind of vectors because I have calculated in that way. Okay, so these are kind of vectors. Okay, two vectors. But if I don't know the angle between them, then how do I get the resultant out of this? Okay, let me find out what is the angle between them. So for that, you have to find out what is the phase angle between current and voltage. Okay, in both cases we will just find out the angle, phase angle between the current and voltage. Okay, all right, so look what we get. So cos phi is equal to R by Z. Okay, R by Z. In both cases, let us find out what is this R. R is 100. Z is also, Z we have got, Z share root 2 into 100. R 100, and this is root 2 into 100. So what I get? 1 by root 2. So what is phi? Let us say this is phi 1. Phi 1, this is 45 degree, right? So that means if I say this is my voltage, so in shear circuit, current will be leading by 45 degree angle. Okay, this is ICR. Okay, this is the voltage, battery voltage. Now similarly I can find out what is phi 2. So cos phi 2 will be further r by z. Z means here r is actually 50 and z is again how much? Z is Z was root 2 into 50. Root 2 into 50, right? Root 2 into 50. Root 2 into 50, right? So this 50 goes off. So this implies phi 2 is also 45-degree angle. So current in the LR circuit will be actually lagging behind by 45 degree. Okay. All right. So this figure is not very perfect. Let me just do one thing. I have already got the angles with the voltage. So look this. If this is my voltage, okay. If this is my voltage, this will be lagging I LR and this is ICR. Okay, so in between them the angle is 90 degree. So what I can do, I can actually find out the current I is equal to, see, ICR means I1 and ILR means I2. So I can now have two vectors in the rectangular Cartesian coordinate system, right? So I can find out ICR whole square plus ILR whole square. Okay, what is CR? ICR. What is ICR? ICR is I1, that is square root of 2 by 10. Square root of 2 by 10 whole square. LR is square root of 2 by 5 whole square into A. So this will be, so the square root of 2, this will be 2 by 100 and 2 by 25. So um, root 2 . So let us find out what we get here. 2 into 4 plus 1 divided by 25 into 100. Okay. So this is 5. 5/20s are this. Okay. So 25 into 20, that would be actually 500. Okay. So 2 by, so this will be 2 by, no, I don't have space. Let me go here and see. Let us do this thing. So I will be is equal to square root of ICR plus so ICR is root 2 by 10 as I said. So we had 2 divided by 100 plus 2 divided by 25. So this is where we were square root 2, this is 1 plus 4 divided by 2, 500. This is then 5. So 2 into 5 divided by 2 into 5. 2 into 5 divided by this. So this 10 will actually be like this. Somehow, let me just cross check once. Somehow I get here 50 ohm, and this is 0.5. Okay, so according to the figure, I am getting this thing, the same thing. Okay, just a minute. I'll just do a quick recap. So ZCR is fine. That is okay. And what is ICR then? 20 by, so root 2 by 10. ILR ILR is doing this. Z will be in this case 50 root 2. Okay, so these are the things actually. Now I have to get sum of these two will give me the resultant. Okay, that means 2 by 100 plus 2 by 25. Okay, we have to put this value, like we have to find out this value. Okay, so this will be J 0.00 0.02, sorry, 0.02, and this will be 0.8. Okay, 0.08, it will be 0.08. Okay, plus 0.02. So this will give you actually 0.1. 0.1 is 0.1. So 0.1 will be 1/10. Okay, so 1/10, that means 1/√10. This will be nearly 0.316. That means 0.32 maybe. Okay, so this will be the answer actually. Actual answer with this given figure will be 0.316 ampere. Okay, if you go up to second decimal, then 0.32 with approximation. Okay, this will be the current. But if you just put 200 here, the answer may be different. Okay, so now this question says a light beam is described by E is equal to 800 sine omega t minus x by c. Okay, now let us see the question. An electron is allowed to move normal to the propagation of light. So light is passing through this way, electron is moving in this direction. With the beam of light with the speed 3 into 10 to the power 8 meter per second, what is the maximum magnetic force exerted on the electron? So magnetic force means Q into V cross B, right? V cross B. This is the force, magnetic force, and this will be maximum when the angle between B and V will be 90 degree. V is the speed of the electron here, and B is the magnetic field in the region where the B is there. Okay, it is perpendicular. V is perpendicular to B. That is what it has to be. So QBB. Okay, but what is B here? B is not given. What is given is E0. So we have to find out what is B0. B0 is actually C, the speed of light multiplied with E0. Okay, speed of light is 3 into 10 to the power 8. Just a minute. I'm sorry, this will be E by C0, not E into C0. E by C0, because E is equal to CB0. Okay, so now E is 800 and C is 3 into 10 to the power 8 meter per second. So what is the force? Magnetic force will be Q 1.6 into 10 to the power minus 19 Q V. V is given 3 into 10 to the power 7 meter per second by 3 into 10 to the power 8 meter per second multiplied with 800 here. And if you multiply, see, so you can just forget about this calculation. This is very easy, you can do anytime. So what was the critical point here? You have to think, you have to, by thinking, you have to calculate what is B0. Once you get B0, then force will be automatically found out. See, magnetic force Q, that means 1.6 into 10 to the power minus 19. Okay, QV, V is 3 into 10 to the power 7 meter per second. QV and B is actually 800 divided by 3 into 10 to the power 8. Okay, now look, this 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 3 is also will go, 1 0 will go, so 1280, but this minus 19 will be there. So what I'll get, I'm sorry, this is actually in Newton. So what I'll get, 12.8 into 10 to the power minus 18 Newton. Okay, so option number C, this one will be correct answer for this question. Okay, so this question says a source of light is placed in front of the screen. Intensity of light is I. Okay, so two polaroids P1 and P2 are so placed in between the source of light and the screen that the intensity on the screen will be I by 2. Okay, so let me tell you, this is from polarization. Let me explain up to I by 2. So when you have polaroids actually polarizes the light, and how it polarizes? It polarizes along the line, okay, or optic axis. Suppose I have unpolarized light which has intensity I. After passing through a polaroid, only you have vibrations of one type which is parallel to, so this is electric field vectors. So electric field vectors having vibration along the optic axis. This is optic axis. Okay, this is optic axis of the polaroid. Optic axis it is called. So you will get only these lights. Okay, so the intensity will be I by 2 here. Now if you keep another polaroid before the screen, suppose this is the screen, this is the screen. If you keep the second polaroid P2 with the optic axis parallel to the P1, then same intensity of light you will be seeing in the screen. That will be I by 2 only. There will be no change because same vibration of electric fields are passing through this easily. You are getting all this polarized light. So this is actually polarized light now. So it is unpolarized light which has intensity I. Okay, unpolarized light. And after passing through the polaroid, the light will be polarized and intensity will be cut down by half. Okay, this much is fine, but at what angle this optic axis has to be rotated? By rotating the polaroid P2 such that so you have to see, earlier your optic axis was like this. Okay, now your polaroid has been rotated. So after rotation, see, whenever there is light passing through a plate or polaroid, the intensity of the light will be, see, I is equal to I naught, the previous intensity or the maximum intensity, cos square theta. So in this case, look, after passing through the second polaroid, intensity has become how much? 3I by 8. Okay. Then what is this angle? What is this angle theta? Okay, we have to find out that. So for that, I'll just write I prime is equal to I by 2 into cos square theta, which is equal to 3I by 8, that is given. Okay, let me write down here. So I prime is equal to I by 2 cos square theta, which is equal to 3I by 8. This 8, 4, I cancels out each other, and then cos square theta means 3 by 2. Okay, so cos of theta will be root 3 by 2, which is cos of 30 degree. So theta will be 30 degree. So you have your unpolarized light, then you have a polaroid. Suppose optic axis like this, then you have to keep the second polaroid P2, so this has to be 30 degree. Okay, so what is the angle? This is the question actually. P2 should be rotated by an angle of dash degrees, so that the source of light and screen, that the intensity of light screen so that the intensity of the light on the screen will be 3I by 8, and that angle is actually 30 degree. We have calculated it, we have understood it. Now I think this is the last problem for this session. A circular coil of radius 8 centimeter and number of turn, suppose capital N, number of turns in the circular coil is 20, is rotated about vertical diameter with an angular speed of, angular speed means this much only, rad per second, given. So a circular coil, that means this, suppose this is a circular coil which is actually having how many turns? 20 turns, having 20 turns. Okay, this is N. Area of cross section radius is given. Okay, radius is given, and this particular circular coil is actually rotated about an axis about its vertical diameter. Vertical diameter means this one. This one is vertical diameter. It is rotated about vertical diameter in a region of uniform magnetic field, horizontal magnetic field. So you have horizontal magnetic field like this. So horizontal magnetic field is there, and in that this is rotated with certain angular velocity omega. So the maximum induced EMF in the coil will be dash into 10 to the power minus 2 volt. So this is very simple, dear students. You know this phi will be B into A, N into A, right? N is the number of turns into A. So you have to remember this. Phi is B A N, B A, and this is the number of turns, total turns. Okay. So now B is given, A I will get what is N, N is the number of turns given. But how to find out? Say this B expression, you know, B A N cos of omega t. Okay. Now, if you want to find out what is this, so EMF will be B A cos of omega t, then omega sine of omega t. Okay, B A omega sine omega t, and maximum means it will be B A omega, and there will be N also. B A omega N. That's all. Okay, B A omega N. So B is given 3 into 10 to the power minus 2. A is pi. Okay, I think I'll just clean this portion so that I get some space. Okay, guys, look here. So EMF will be B A N into omega. So what is B N and omega? See, this cos theta term will come, B A N cos of omega t, right? So that will make it is sine omega t. For maximum value, B A. Okay, so B is 3, sorry, B is something in 24 minus 3. Okay, so if you put this all values, okay, B, A, N, omega, then you'll get the value to be nearly equal to 60.28. Okay, do this calculation. This is very simple calculation. You have to just multiply and find out the answer. Okay, so this will be the answer. So 60.28 and nearly equal to 60. I can say nearly 60. Okay, so I think with this I'll stop it here for today. In the next class we'll take again for the 11th standard and finish it up. Okay, so thank you for your patience. Bye for today.